Okay, this is a very favorite subject of mine, how to test the SONiC. My name is Taskin Ucpina. I work for Edgecore. I'm one of the directors in the company. During this presentation, we're going to talk about how do we do the testing, why do we do the testing the way we are doing the testing, how we make the partners productize a given SONiC release. This is a little bit boasting about the Edgecore. We are, I think, the biggest vendor, or the vendor with the most hardware that supports the SONiC releases. As of today, we have 17 different devices that's certified for SONiC. And in any version that comes out, it goes through the same process. We validate the hardware, make sure that everything is working. A very large array of devices. They go from 16 ports to 128 ports. That 128 ports is mini pack. It supports 100 gig ports, 128 of those. So it's a very wide margin of the devices. Why do we care about the SONiC testing and the growth? Well, the feature set grows really a lot. It covers a very wide margin of different functionality, and testing is very, very important. It's not just for the testing for our devices, it's also testing for, in general, the other even the competitors' devices. Because whenever a SONiC release is coming out, we're just not testing our devices. It has to be working with the other vendors' devices as well. And of course, it has to go through regressions and CI/CD, so that in time we're fixing a bug, it's validated and it's functional. How do we do the regression testing? Branching is very, very important, and it's in an important case where there's releases and the releases that we maintain, and they are different subjects. We have to make sure that we got a full picture of everything, and the coverage is in full, or at least as full as we can. Of course, it needs to be also hardened, and we have to go and support the community to make the same functionality available for partners and users. I'm going to talk about a little bit about releases and try to describe why this is a little bit challenging for us, or not just our company, it's everybody. Generally, the SONiC releases are 3 to 4 releases a year. Actually, it's been targeting 4 releases. It generally happens 3, but you can pretty much count on the fact that there are going to be 3 releases coming out at any given time. But when a release comes out, there's a branch. The sources are branched so that any functionality can be implemented in the main line. And the bugs can be fixed on the branch. And when I say bugs, there are quite a few bugs. Some functionality hasn't been tested, some functionality has been tested not in full. So after the release comes out, there's a number of bug fixes that starts coming into the branch. And 4 months later, there's another release comes out. But that doesn't mean that we are going to be always stopping the bug fixes in the original branch that we started with. In this case, 1803. After 1807 comes up, there is still bug fixes, although they are much less, but there are still bug fixes coming in. Of course, 1807 goes through the same thing. There are bug fixes going on, while other branches are also getting bug fixes. And this just keeps happening. Except the bug fixes don't go this way, right? I mean, if somebody pulls a PR saying that, okay, I'm going to go ahead and fix this bug, and it's a submission of, please let me go ahead and merge this change in. That doesn't mean that it's going to be merged in immediately. At some points, I've seen, I think, about like 72 PRs pending for approval. And they just pile in. And I think that's one of the issues that we've discussed with Microsoft as well. There used to be only a single engineer who checks these bugs, validates the features, and then comes to the branch. That means whenever a PR, there's another PR that quite often comes in, and later on, sometimes after the vetting, that original bug code change goes in, and the second one goes in. There is always a delay, and that delay is sometimes really extensive. What do I mean with this? How do we handle this? If there's 70 bug fixes that's pending, and we know that they are most likely, but not for sure, most likely okay. How do we handle these things so that our customers can use these things? How do we make sure that our devices are validated and certified based on this release? Well, when the bug, when a release is branched out, we also make a copy of that branch. It's exact one-to-one copy. However, what we do is we start monitoring what's going on in the main line and also the original branch. And anytime there is a PR that comes in, our engineers, we have about 40 people, they mostly try to automatically try to take these bugs in immediately. So we don't wait for the approval for these bugs going into, or the changes going into the branch, or the original release branch. We start taking them immediately and start running our test cases immediately. And I'm going to explain why in a bit. Also, we keep monitoring what's on the main the release branch. Sometimes we revert the bug fixes that we took in from the PR state. We revert them back and get the real ones when they are approved from the release branch itself. That means we are syncing up with the release branch and we're syncing up with the PR request at the same time. Whenever the next release comes in, the same story happens as well. We took another branch, we start immediately pulling the sources in, except we also start fixing bugs by ourselves as well. So we are taking the changes from the PRs, we are taking the changes from the official release branch, and we are also contributing our own fixes, and we are pushing those changes back upstream as well, so that the release branch is stable as well. And this happens on a very regular basis. If you think that this is the end of the story, it's a little bit misleading, because there's one more thing. We also use source code from certain vendors, where we have dependencies on certain SDKs. We also maintain those dependencies and the fixes by ourselves. Sometimes those vendors may or may not agree on including the fixes that they have found in their own release. There's always a convincing negotiation thing going on. Sometimes they don't want to fix the bugs. So whenever there is a bug fix that we found on the third-party components or the SDKs we're using, we add those into our own repository. And we keep applying those changes with sometimes a little bit modification, so that we can make sure that the release is more and more stable. So, and whenever they come up with a new SDK version or a new component version, we update our patches for that version. And this is happening for every single different release of the SONiC and their own SDK. So this is literally what happens any given time in Edgecore for any given device. We merge the changes coming on from multiple places. How do we test the releases? Why do we test the releases? If you look at the history on what the SONiC releases are, for example, on 17.05, there is BGP. Yes, there's a BGP test case included. There's no ECMP test. Or maybe there is somewhere, we just don't know. It's not included in the SONiC release. When you look at the 17.09, IPv6 was included on that release, but there's no IPv6 testing. I'm pretty sure it's done somewhere, it's just not as a part of the SONiC. But we still need to make sure that it has to be tested, right? Why? This is a quick summary of what the releases, SONiC releases versus the number of tests with each feature included. At the beginning, or earlier 17.05 release, there were 18 new features and only 9 test cases, or test suites, I should say, for each of those features. Then it started going down a little bit. Like as the time passed by, instead of 50% of the new features including a test case, it just started getting less and less. Today, if you look at the 19.04, 16 new features were added, and only 5 of those included test cases. There is a big gap. And we still have to go then make the devices certified, and we need to still have to make the devices validated so that the customers can start using it. So what do? We add unit tests. I'm going to go through a little bit fast. I know we're running late on the schedule. We write unit tests, we write functional tests, we write component tests. This is not just for verifying the functionality, also the team is fairly young. We are trying to teach the younger engineers how to test the functionality. We are trying to teach our partners how to test a functionality, how they verify the functionality, not just by using our devices, but their own devices as well. We make sure that all the developers are, whenever they are making a bug fix, a feature test identifies a gap, they are writing a unit test. But not they are only limited to unit tests. We also force our developers to write some of the functional tests as well. It's not just the QA's responsibility. Our developers have to go ahead and write the test cases as well. For unit tests, of course, we are using GTest, we are using PyUnit, but also we are running the SONiC's Ansible test cases. What does it mean? When you look at the 1904, I gave that example, 62% of the functionality that was released, it didn't include a test suite associated with it. 62% is a very large number. The coverage is unknown. That means if there's a test suite there, we really don't know how much the test suite is covering the functionality. And stability is really unknown. There's no measuring of it. The goal is to get to the 100% coverage. 100% coverage is not on the source code coverage. Anytime a new release comes in, we want to get to the 100% test feature coverage. That's the first goal. Stability still is unknown, but at least for the functionality that doesn't have test suites, we add those test suites. We add those test features to be tested. Of course, it has to be automated. Anytime the release comes in, we have a system that goes and figures out where the test cases are, including from ours and coming from the community, and starts running regression. And that is a big deal. I'll tell you why running the regressions on this case is, for us anyways, it's a big deal. Of course, when those all are done, we look into the hardening of the functionality. How do we make the changes so that the stability is improved? Not just for the SONiC, also the test cases. Whenever the test cases come in, it doesn't mean that they are stable. Sometimes when you run the test cases, the resulting environment is really unstable. How do we remove the effects? Is very big focus. We have a big focus on making sure that everything is stable. And of course, we have to go ahead and add test cases. How do we do this? We have a number of test labs. Those test labs are available through VPN. Not just to our engineers, but also certain partners and customers. When the engineers or the partners get the access, they can VPN into it, they can access our devices, and some certain cases, even the competitor devices. Of course, we do have packet generators, SONiC and Exia, so that they can push the data in, test the functionality, verify that everything works by using our devices on our labs. Just quickly touching base on why this is so big of a deal, and what do we offer with these labs. Not just our engineers, but also the customers or the partners. When they come in, they get a AWS server. It's dynamically created. It includes all the build environment already set up for the customers. Even the access to sources, our sources, or our version of the sources, although they may not be committed yet into the open source repositories, they have the access. They can just go ahead and run the builds. They can make changes. They can go ahead and submit a fix if they find an issue in our fixes or even the test cases. It goes through a very simple CI/CD process. We run sanities, we do code reviews, static analysis, performance is measured. It doesn't have coverage for 100%. I'll explain why it doesn't.
Can I ask a question?
Sure.
What type of static code analysis?
Cover it.
You run it entire on all the SONiC?
Portions of it. We don't run it in everywhere. When you run a static analysis test case, it may identify, for certain components, it may identify issues that are not really issues. That's why we try to focus on, okay, let's go ahead and make sure that this functionality is new. Let's run it on this functionality only. Plus, running static analysis includes also running a build in addition to the original build, which takes about, 5.5 hours, 6 hours. So if you run the entire static analysis on the entire sources, it becomes really, really long process. And people don't like waiting for their code to be approved, to be going into our repositories. They don't want like a day of waiting. And I'll tell you why a day of waiting is really not that of a long deal. But it's a good question. Static analysis is, I think we are running as much as we can. Regression unit testing and regression functional testing is also run, but very limited capacity because regressions take a very, very long time. And I'll tell you about it, like why it takes a very long time. This is our generic functionality on how we run the regressions. We have GitLab, and anytime we need an AWS server, we create it automatically. We run the builds, we put it on the Artifactory, and we run the test cases. Very high level. Getting into a little bit details is actually this is where the importance or the timing comes into picture. We have the sources, but we don't have only a single target there. We don't run only a single build. When we run the builds, sometimes you have to go ahead and run multiple binaries. You have to generate multiple binaries. You can go ahead and put them in sequence, but then you're going to be waiting 5.5 hours. It just keeps adding up. And when you increase the build time, it's eating from your 24 hours when you're running the entire regression in a single day. So sometimes we go ahead and create AWS servers automatically, run the builds in parallel. Sometimes some of the object code is generated double, but at least it saves us time. It is very common that we run 3 or 4 builds at the same time. All the results go into Artifactory. On certain regions, we also distribute the Artifactory artifacts into multiple regions so that it is accessible from Europe and also as well as US and Asia. When you're downloading a gigabyte of file from US, sometimes it takes a long time. If you're in let's say Asia. We have a Jenkins process that monitors the builds coming out, goes and creates additional AWS servers. They are very small AWS servers so that we don't spend too much money on the CPU and memory cost, but it is simply running the test cases. On certain cases, we go ahead and get the test bed. We upload the image, if we need to upload the image, and all the time we don't have to upload the image. If we do, it takes a very long time, because we run over 234 test cases. So every single time if you're updating the targets, it is a very time-consuming process. But the controlling script uploads the image if it's necessary, or changes the configuration, tries to get it into a clean condition, runs the test cases, gets the results, gets the log files, because some of the Ansible test cases, they may say everything is okay, but if you look at the logs, they are failed. And this is some of the issues that we are addressing with the community. We are updating the Ansible cases from the community as well. The results are collected. They are sent to Jenkins, and the final report is generated. Why is this a big deal? If you run the full test suites of 234 of those, with as little as build, as little as uploading the image, as little as configuration changes possible, we try to avoid them. With a single test bed, it takes 71 hours. It's a very comprehensive test case now. All of a sudden, your regression is not running in 1 day or 2 days, right? It's 3 days. So what you do is you just go ahead and add another device, divide your test cases into 2 test beds, and run them again. If it's not enough, you add another one. If it's not enough, you add another one. It's not a linear cut in time, because your build time is still the same. It's about 6 hours. So whenever you're running the regressions, you spend the 6 hours, and the rest is spent on running the test cases. In this case, for 7816, we have to run 4 test beds to run the entire test suite in 24 hours, so that the next day we can do the same thing again. And we have 17 devices, by the way. We are Edgecore, so we may have a little bit access to hardware. Okay.
Are you running internet topology? Fixed topology?
Oh yeah, of course. We have fixed topologies that we verify. I'll give you a few examples of those. Yes. Depending on the hardware, it's not really depending on the hardware. It's mostly the same. Okay. It's mostly the same, but you have to go and still verify the fact that that device is tested in the same way with the other ones. At the end of the day, we are using SDKs from other vendors, for example. So it has to be tested on that specific device. If you look at the contributions for 1904, you'll see that we run unit tests, we fix issues on SONiC, and we fix even the issues on test cases. When you look at only 1904, the total number of contributions is about 65. So, and this is on a release branch. And this is just from our side.
On which type of tests or features you are testing?
I'll go back to the, yeah. All of these and more. When anytime there's any feature comes in, we try to include a new test case, or if there's no test case, we implement one. If there's a test case, an Ansible test included in SONiC, we run that one as well.
ECP, BGP, LAG, LLDP, they are all available in upstream. So you are adding more? Or
We are adding more.
what is available?
We are testing what's available, and we're adding more.
Okay.
That's what I was saying in here in this slide. We try to get the full coverage. And full coverage is not in terms of the code lines of coverage. The full coverage is in terms of the features.
And if there is a test, for example, for DBG, BGP, I think that there are like 4 of them.
We run 4.
So you are adding test cases to those that exist, or you're creating another one?
If there is a test case available, we try to go ahead and make sure that it has a good coverage. If it doesn't have good coverage, we try to add unit test cases. That's how we start with.
And unit case is the virtual switch?
Um,
What is a unit case in your
unit test is we look at the functionality, and if that functionality has been exercised or not. If that has not ever been exercised, although there is what you call an Ansible test case coming from SONiC, we write a unit test to go ahead and verify it. For example, ACL test cases. We write a good number of ACL test cases.
Yeah, but what I'm asking is, what is the unit test? Is it in a real hardware or virtual switch?
Oh, it's always hardware. It's always hardware.
Okay, and so it's an Ansible test?
Not necessarily. Like when we're writing the what you call unit test cases, it could be some. In most cases, it's C.
You run them. Currently, maybe I'm missing something, but as far as I know, the SONiC management includes mostly Ansible and Python's test.
Yep. So what I showed you here is I glanced through this one quickly. If when we run unit test cases, they're automatically included in the G test. It's Google test.
Ah, okay.
Yeah. If you run Python test cases, which is a little bit higher, it's not really unit test, it's a little bit higher level, then we use PyUnit.
So I think they added some G test in the SWSS report.
Okay, and how you execute those tests?
Huh?
How you execute those tests?
I think currently, in the PR it was disabled. It is disabled. So the G test they submitted currently is disabled.
They are not running. They are not running. We're running.
Go ahead and write every PR.
Yeah.
Okay.
Yeah.
What does it mean in real life? This is again the 1904 on 7816. When 1904 came out, when we ran the full test cases, we had about close to 90 test cases that we identified, the features that failed. Over the next few weeks, we make code changes. We make sure that the test cases are passing, either updating the SONiC or test cases, or we're adding new test cases to validate the functionality. We fix the issues from the third-party components. And as you can see, the number of bug counts go fairly significantly. Once in a while, as you'll see here in this one, is on 0823, there's a spike. That means it's either somebody changed the topology. It does happen, somebody disconnects a cable, although they shouldn't. We all automatically detect that because it's very visible. Although you had normally 20 bugs or 20 failures a day, it becomes 40. It's impossible to not to notice it. The next day it gets fixed, but maybe next day somebody else goes and makes a code change that's really breaking something, but it's again noticed very fast, and the issues are immediately addressed. That's how we validate the test cases and certify our releases. I know I went really fast, but I think I'm on time, or very close. I'll be happy to answer your questions if you have any.
Actually, thanks for the analytic work of what's failing and what's changing and what's missing. Actually, my question is very simple. Can you share the plan of contributing some of the tests or all the tests to the community? Each party are working on documentation on contributing features. Would love to see more contribution in test part. That I know that you have, but
Right.
you seems like you have a much fuller, like unit test, PyTest.
The framework itself, actually, we are really trying to contribute the framework itself to the community, so that like others can run. There's issues with how do you manage the framework itself, and how do you manage the SDKs coming from the third parties. How do you manage the code fixes that's on the PR waiting list that we are automatically trying to pull in? Because whenever we try to pull the PRs automatically, for the most part it works, but sometimes the merges are not correct. This is coming from the fact that sometimes there's code dependencies between the PRs, and the order is very important. We just go ahead and merge the changes in the way that they have been submitted, and they may not always include the changes that's caused by the previous commit. That's what Microsoft does. When they do commit, it's very orderly. When we're pulling these things in, it is a little bit. It causes some issues at times. So there's literally you need a dedicated team to monitor what the changes are and make sure that the changes are not breaking anything else. And sometimes, quite often, you have to go ahead and modify the changes manually to make sure that nothing is being skipped. But we are definitely looking into how we're going to commit this framework back into the community itself.
Okay, yeah. Let's have a chat after that. Then.
Perfect.
Thank you.
Perfect. Thank you. Any more questions? Perfect. Thank you, guys.